Search for NASA power data. Click on the first link. Then look for methodology. And look for Power Data Access Viewer. Takes a bit to load the page. Once loaded, click on Access Data. On the left-hand side, you have a settings window. You want to select renewable energy in the first step, climatology in the second. In the third, you put in your coordinates, the latitude and the longitude. You can get those from Google Maps, or you can choose your location with the pointer. I will choose a random location. So we are in Australia and Sydney, and I just put the pointer somewhere. So now you can see in step 3, it has selected the latitude and the longitude. Step 4 is the time extent, and step 5 is the output file formats. Let's select ASC2 and CSV. In step 6, you select the parameters for solar design. This is the meteorology temperature. Here you select maximum temperature 2 meters and minimum temperature 2 meters. Then you go to the last one, tilted solar panels, and here you want to select the first minimum solar irradiance for equator facing tilted surfaces. Once done, you click submit. Takes a while for the page to load. Once done, you can get your data in ASC2. Here you can see the different temperatures for each month of the year. What we are looking for is the minimal optimal annual temperature, which is the 4.02 here. This is an example of an electricity bill. We are going to calculate how much power a solar power system needs to generate for this particular case, using simple calculations. On this electricity bill, we see energy consumption for 1 year from January 2019 to January 2020. We have an average daily use in kilowatt hours, which is the 4.06 kilowatt hours. And we are going to convert this 4.06 kilowatt hours in watt hours. So multiplying by 1000, which gets us to 4060 watt hours. Divide the 4060 watt hours by the average sun hours in your area. This is the number we obtained from the NASA website in the previous step. We get the power consumption in watts, which is 1009.9. There is a loss factor for PV systems of 1.3 that we have to incorporate in our calculation. So 1312.9 will include the losses in the system. In our example, we want 80% of solar generation because of budget or available roof area. So we multiply by 0.8. The solar power system will be 1050.3 watts for 80% of the total consumption of this particular house. Search for ABB string sizer. Click on the first link on ABB page and go to ABB string sizing tool. Then fill some settings. In location, you select English or continent Oceania, country Australia, as in our previous example, and Sydney. For temperature, you select Celsius or Kelvin. And flush on roof. Ambient temperature and cell temperature values, leave them by default. PV panel selection. Select the type of panel. For this case, we will select Canadian Solar of model of 260 watts. On the left-hand side, we have the technical data of the solar panel with all the parameters as nominal power, voltage, current and temperature. Step 4. Inverter selection. Select grid type according to the country based and the model of the inverter. In previous calculations, the output power required for a solar system was 1050.3 watts. For this case, we select an inverter of 1200 watts of rated active power. Step 5. Results. The tool suggests to have only one string with 5 solar panels connected. If you click on the configuration report, you see the technical data of the inverter and solar panels, also the number of the panels and strings used for this case. Please take into account that it is only an estimation of the number of solar panels and size of the inverter. For more accuracy, consult your local solar company provider.
Tell me pretty lies, look me in the face. Tell me that you love me,